Hi, it's me. Were you surprised? Did you expect someone else? Just me. All right. We are finishing module 7. This is lesson 6, practicing addition and subtraction using equations. So I think the tricky part from class today, the tricky part was knowing when we are adding or when we are subtracting. So let's take a look at our page. And there it is. Let's see what we can do. Our first problem says one balloon is 3 7/10 meters above the ground. A second balloon is 2 3/5 meters higher. How far above the ground is the second balloon? So we have a little picture here to help us. So we know there's one balloon, 3 7/10 meters off the ground. The second balloon is 2 3/5 meters higher. That's important. We need to make sure we recognize that it is the same distance and then a little bit more. How far above the ground is the second balloon? Now, just like we were doing in class, we need an addition equation and a related subtraction equation to model the problem. We're going to use B to represent the height of the second balloon. So what could we do to solve? There are a couple of choices. We could do, if one balloon is 3 7/10 off the ground, and the second balloon is 2 3/5 meters higher. I said fifths and I wrote a 5. 3/5 higher, that would equal B. The 3 7/10 and the 2 3/5 higher would equal B. Now, a related subtraction fact or equation, sorry, we could say B minus 2 3/5 equals 3 7/10. So that would be, we don't know how much higher, so we would subtract the 3 7/10. I'm sorry, subtract the 2 3/5 higher, and then this part that is left up there, we know that's 3 7/10. I don't know that that made sense. I hope the equation makes sense, even though my words may not have. All right, estimate the answer. Let's estimate 3 7/10 using our benchmarks. 3 7/10 is about 3 1/2. Let's see, we need to know how far above the ground is the second balloon. So we're going to say plus 2 3/5 is about 2 1/2. So our answer is about 6 meters off the ground. Let's do the real work. Let's use our original equation. We have tenths and fifths, so our common denominator can be 10. 3 7/10 is going to remain the same. I'm going to rename 2 3/5. That would be 2 and how many tenths? 2 6/10. And that's going to equal 5 13/10. Now, because the fractional part is improper, we're going to keep our 5 and we're going to add, let's rename this improper fraction as a mixed number to add to the whole number we already have. 10 goes into 13 one whole time with 3/10 left. When we add together, we get 6 3/10. And we're talking again meters. Compare our estimate to our answer. Is it reasonable? Yes. Our estimate is close. Sorry about that. Our estimate is close to the real answer. All right. If our estimate is close to our real answer, it makes it reasonable. Okay, model with mathematics, it says next. Nellie watched 2 movies on Saturday. The second movie lasted 2 3/4 hours. Nellie spent 5 1/3 hours watching both movies. How long was the first movie? So the second movie, that's important, lasted 2 3/4 hours. She spent 5 1/3 hours watching both movies. So we need an addition equation and a related subtraction again. And we're going to use, we don't have any, they're not telling us a letter to use to represent how long the first movie was. We're going to just use an M for movie, okay? So both movies, I know the total for both movies. What I don't know is movie 1. I don't know how long that was, but I know if I add that to movie 2, I get the total of 5 1/3 hours. A related subtraction problem, I can take my total and I can move it all the way to the front of my equation and then subtract how long the second movie was, and that would equal M. So those are our equations. How long was the first movie? I'm going to look at this equation. I have thirds and fourths. My common denominator can be 12ths. So I have 5 4/12 minus 2 and how many 12ths? If I have 3/4, how many 12ths is that? 9 12ths. When I look at the fractional part of this, I have 4/12 minus 9/12. So we've talked about 3 different ways in class that you could do this. I'm going to rename my lead fraction. I'm going to take 1 away from the whole number. 5 minus 1 is 4. Then I would have that 1. It's 12/12 plus my 4/12. So I have 16/12 now, minus 2 and 9/12. 4 minus 2 is 2. 16 minus 9 is 7/12. And we're talking about hours if we're going to label that. 2 7/12 hours. Okay. Model with mathematics. Let's see what's happening here. Beth's summer vacation lasted 12 3/7 weeks. Whew. At the beginning of her vacation, she spent some time at soccer camp and 2 4/7 weeks at her grandmother's house. She then had 6 6/7 weeks of vacation remaining. Write an equation to model the situation. How many weeks did Beth spend at soccer camp? So her whole vacation, the whole thing was 12 3/7 weeks. She spent some time at soccer camp. We don't know how much time at soccer camp. We might have to assign a letter to that. How about we say soccer camp? Let's make that. I don't like S's and C's. We can use an S for soccer. All right. 2 4/7 weeks at grandma's house. And then she had 6 6/7 weeks remaining. That's a lot of information. So we need to determine how many weeks she spent at soccer camp. What kind of an equation can we write? Because it says write an equation. So if we know the total number of weeks she had, 12 3/7, we take away the weeks at grandma's, 2 4/7, and she has, after soccer camp, if we were to take away soccer camp, she would have 6 6/7 weeks left. So that could be one equation for us to solve. Another thing we could do is we could take, let's see, she had 2 4/7 weeks at grandma's. She had 6 6/7 weeks. Oh, that was remaining. Oh, left over. Yep. And she had some soccer camp, and that all equaled 12 3/7 weeks. So we could take all the different parts of her vacation, and we know the total, we add up those other parts. So those are 2 possible answers for the equations we could write. And then we could find our total answer here, what W equals. They're all sevenths, so Let's see. I'll do this one. 2 plus 6, that's 8. And 10/7 plus soccer camp equals 12 3/7. So then I'm actually going to, hope I don't run out of room. I'm going to say, all right, if we know 12 3/7 and we take away the 8 and 10/7, that's going to equal our soccer camp. Woo! 11 and 10/7 minus 8 and 10/7 equals 3. That's going to be our answer. She had 3 weeks at soccer camp. Ooh, some of you would love that. All right. There's our review of the lesson. The next side, we have our test prep. So let's see what's going to happen here. Test is coming up. This was our last lesson. Ms. Lee stores flour in a jar. She buys 2 7/8 pounds of flour and puts it in the jar. Now the jar holds 4.5 pounds of flour. How much flour was in the jar before she made her purchase? So this is what she bought. And now she has this much. So what was in there before? How much was in? I know her total is 4. I just wrote over it, 4 1/2. And I know if I take out what she bought and put in there, that should give me how much was in there before. So let's evaluate this. I have 2 and 8 for a denominator. I'm going to change my lead fraction to 8ths. 4 4/8 minus 2 7/8. Well, I'm going to have to do a little bit of work. Let's do the Columbia C on this one. I have 8 times 4 is 32, plus 4 is 36/8, minus 8 times 2 is 16, plus 7 is 23/8, which would give me 13/8. I can't leave it like that. That's improper. 8 goes into 13 one time with 5/8 left over. Looks to me like that would be letter C. Next, a beaker holds 3 9/10 liters of water. A bowl holds 2.5 liters more water than the beaker. How much water is in the bowl? So here's the beaker, 3 9/10. The bowl is 2.5 liters more. So if we have the beaker and the bowl, how much more water is in the bowl? So 3 9/10, that's our beaker, plus the bowl is 2.5 more. There was my clue word to add, equals, let's do some adjusting. I have tenths and a 2 for halves there. I'm going to leave my lead fraction and I'm going to adjust. 2.5 is 2 and how many tenths? 2 and 5/10. So we have 5 and 14/10. Again, I can't leave it like that. 14/10 would be 1 and 4/10, plus my 5 would be 6 and 4/10, and we're talking liters. So we have letter A. Trying to keep my work separate over here. All right. Terrence completes 9 laps around a track. He runs some laps, then walks the last 1 3/4 laps to cool down. How many laps did he run? A total of 9 all around. 1 3/4 of those was walking. Whatever's left was running. So we have 9 minus 1 3/4. I'm going to do this the way some of you like to do it. 9 minus 1 equals 8. I don't have any fraction part here, so I have minus 3/4. Let's see if this works. I now have to adjust my lead fraction. 7 4/4 minus 3/4 equals 7 1/4 of those laps were running. So it did work. If you do it that way, some of you just need to remember that minus sign has to stay in there to do that. If that doesn't make sense to you, don't use that one. Use the Columbia C or adjust your lead fraction first. All right. Mako buys a bird feeder that can hold 3.5 pounds of sunflower seeds. She has 1 9/16 pounds of sunflower seeds. How many more pounds of sunflower seeds does Mako need to fill the feeder? It can hold 3.5 pounds total. Can hold. She has 1 9/16 pounds. So the total it can hold is 3.5. She has 1 9/16. So how many more? That's a big clue, right? How many more does she need to fill the feeder? So we're going to subtract. I'm going to adjust. I have a 2 and a 16 in my denominators. My common denominator can be 16. So 3.5 is 3 and how many 16ths? 2 times 8 is 16. 1 times 8 is 8 minus 1 9/16. Now, I can't do 8 minus 9 without doing some adjusting. I'm going to rename. I'm taking 1 away from 3. I'm adding that, then that 1 becomes 16ths. So I have 16 16ths plus 8. So that's 24 16ths minus 1 9/16. 2 minus 1 is 1. 24 minus 9 is 15 16. So I believe 1 15/16 pounds more. Okay. Remembering that we're going to label our answers and we have to write them in. Roberto measures his pencil to be 2 5/8 inches long. His friend Hakeem's pencil is 1.5 inches longer than Roberto's pencil. Write an addition equation and a related subtraction equation to model the problem. How long is Hakeem's pencil? So 2 5/8 inches, that's Roberto. Hakeem is 1.5 inches longer. That's important. Our addition sentence, what could we say? Well, we're looking for the length of the pencil. So if it's 2 5/8, that's Roberto. Hakeem's is 1.5 inches longer. That's going to equal his pencil. A related subtraction problem, could we say, well, if I know, let's see, I know Hakeem's pencil is the longer one, and I take away the length of Hakeem's pencil, that's going to leave that 1.5 extra, right? So there are a couple of different answers or a couple of different possible solutions here. Those are 2. So let's work. If we have 2 5/8 plus 1 1/2, I'm going to leave my 2 5/8. My common denominator can be 8. 1 1/2 would be 1 and how many eighths? 1 4/8. And when I add, I get 3 9/8. Now, I have a whole 3. 9/8 is improper, so I'm going to change it to a mixed number and add it to the 3 I already have. 8 goes into 9 one time with 1 left over. So our final answer is going to be 4 1/8 inches. That's our final answer right there. Oh, look, we get to do a little spiral review of order of operations. Parentheses, exponents, multiply, divide, add, subtract. Order of operations, say what? We haven't done that for a while. All right, parentheses, 12 minus 7 is 5. I'm going to bring down everything else and reevaluate. Multiplying comes next. Bring down the beginning, and there's our gold medal. Last one, Jackie works 2/3 hours on a science project. Lucas works 3/4 of an hour on the project. How much longer does Lucas work on the project than Jackie? She did 2/3 of an hour. He did 3/4 of an hour. How much longer did he work? So we're going to do 3, I'm going to go down here, 3/4 minus 2/3 equals. Common denominator for 4 and 3 will be 12. So I'm going to rewrite my fractions both with the 12 in the denominator and then find that numerator. We know if we change the denominator, we change the numerator. 4 times 3 is 12, 3 times 3 is 9, 3 times 4 is 12, 2 times 4 is 8. We get a difference of 1/12 of an hour, and that will be our final answer. Okay, friends, that's it for our final review and lesson in Module 7. Test is coming up. I hope you feel good about it. I hope you feel ready. If you have questions, bring them to class. We will be reviewing and then taking our test very soon. I'll see you next time in class. Bye, friends.